All right. Today we will be in chapter 5. Talking about systems of equations. And inequalities will also show up in this one. We'll start off with section 5.1, which is just systems of linear equations in two variables and applications. All righty. So the very first objective here is to identify, objective 1, will be to identify solutions to the system of linear equations. So we're going to identify solutions to systems of linear equations. In two variables. First example, if I give you negative 11x plus 6y equals negative 4 and 7x plus 3y equals 23, and I ask these two questions. Is 1 comma 7 6 a solution, and is 2 comma 3 a solution? Well, all you have to do is take these values. Remember, this is a coordinate, so it's x comma y, and plug it into both equations. Now, the moment one doesn't work, you're done. But if one works, you do have to check the second one. So let's check the first one. Doesn't matter which one you check first. So I get a negative 11. I'll replace this x with a 1. Plus 6, I'll replace y with 7 6 equals negative 4. And then we'll work it out. Negative 11 plus 1 is negative 11. If I multiply by 6 and divide by 6, the 6's will cancel. So I have 7. Negative 11 plus 7 is, in fact, negative 4. So that part worked out, but you do have to check the second one. So then I get 7 times 1 plus 3 times 7 sixths equals 23. All right, 7 times 1 is 7. 3 goes into 6 2 times. So this is 7 halves. And I can tell you this, 7 plus 7 halves, what you think about it is like 3.5, which will give me like 10.5, is not 23. So this will be a no. So we're going to do the exact same thing to the other one. I'm going to take the first equation, negative 11, replace my x with a 2 this time, plus 6, replace my y with a 3, equals negative 4. 2 times negative 11 is negative 22. 6 times 3 is 18. Negative 22 plus 18 is negative 4, so that one worked. I'll check the second one. So 7 times 2 plus 3 times 3 equals 23. So 7 times 2 is 14. 3 times 3 is 9. 14 plus 9 is 23. So that does work out. So this would be a yes. And that's all you have to do in objective 1. It's literally, they were going to give you some answers. You plug it into both, see if it works out for both. If that does, the answer is yes. If it doesn't, then the answer is no. All right. I don't think we need to ponder on that much. So let's work on objective 2. In objective 2, we're going to solve systems of linear equations in two variables. Now, there's multiple ways to do this. You can do graphing, substitution, elimination. However, they are going to ask you to do it in certain ways. So the first part they're going to do here is ask you to solve by substitution. They're not going to make you graph, which is nice. Graphing's not as accurate, but it is a method. So we're going to solve by substitution. So if I give you 2x plus y equals 2, I give you 5x plus 3y equals 9. You have to decide which variable you want to solve for. All right. My recommendation, look at your 4 variables you have, look to see which one has the smallest coefficient and solve for that one. So I see that y is by itself, so it must be smaller than all the rest of them. So I'm going to solve for y. And to solve for y, all I got to do is move the x over by changing its sign. So this becomes y equals 2 minus 2x. That's step 1. Step 1, solve for y. Step 2, take that equation you just solved for, and you're going to replace the variable with it in the other equation. So since I solved for y, I'm going to replace y. If I would have solved for x, I would have replaced x. So by doing that, I now get 5x plus 3. I'm now going to replace y with this equation. 2 minus 2x equals 9. Now I have a linear equation in which now I can solve. So I will distribute first. So that gives me 6 minus 6x equals 9. I then combine like terms. 5x minus 6x gives me negative x or negative 1x, however you want to write that. Then I will subtract 6. So I get negative x equals 3. If negative x equals 3, that means positive x must equal negative 3. So this is now step 2, solve for x. And the third and final step, go back to this equation that you solved for, and now plug in the value of the other letter to solve for that one. So this becomes y equals 2 minus 2 times negative 3. And I can see that this will be 2 plus 6, which is equal to 8. Therefore, your final outcome would be as a coordinate. We write a coordinate as x comma y. So in this case, this would be negative 3 comma 8. And that's how you do substitution. All right, the other method they're going to have you do is the addition elimination, which is actually one of my favorites. So in example 2 here, we're going to solve by the book calls it the addition. You can also look online, and it's also considered the elimination. All righty. So if I gave you a problem that looks like this, negative 3x minus y equals y minus 14. And then I give you 2x plus 2 equals 7y. All right. The goal is to be able to use addition and elimination. Both equations must be in standard form. Standard form, if you don't remember, is ax plus by equals c, meaning the x and the y is on the left side and the constants on the right side, right? So this is the form I have to get it in. So the first thing I'm going to do on this first equation is distribute. So this gives me negative 3x plus 3y equals y minus 14. And then I see I need to move this y over by subtracting y. So then I get negative 3x plus 2y equals negative 14. You don't have to stress about the a not being negative or a fraction. You just got to put it where the x and y is basically on one side. Once you have it in this form, you want to do the same thing to the next one. All I see here is that the 2 needs to switch and the 7 needs to switch by subtracting 2 and subtracting 7y. And when I do that, I would get 2x minus 7y equals -2. Now, big thing here, make sure you line up your terms. You want to have your x first, then your y, then your constant. Because what we're going to do now, hence why it's called the addition elimination method, is we need to figure out what we're going to multiply both equations by to eliminate them. Now, there is easier ways to do this in a sense that if you can see patterns, you can multiply by certain numbers. But the way I'm about to show you seems to always be working. So what I'm going to do is I'm going to take whatever this number is, and I'm going to multiply the entire upper equation by whatever the coefficient of x is. Then I'm going to do the same thing to the bottom equation, but I'm going to multiply by the opposite sign of what I see in front of this x. So since I see a -3, I'm going to multiply by 3. Now, by doing that, this will give me -6x plus 4y equals -28. Do make sure you multiply that coefficient or that constant. That's usually what gets forgotten. Do the same thing on the bottom. 3 times 2x is 6x. 3 times -7 is -21y. And 3 times -2 is -6. Now, again, I say that you can literally multiply these equations by all kinds of different numbers. But my experience, this has been the easiest process because it works out every single time. So all I got to do now is add these, like hence again why it's called addition elimination. And it's called elimination because when I add these two up, I will eliminate one of my variables and we'll always be eliminating the x. I mean, it doesn't have to be, but if you do this process, it will always eliminate the x. So -6x plus 6x is 0x. So that gets eliminated. And then 4 plus -21 would be -17y. -28 minus 16 would be -34. And then we would divide by -17. So that means y equals +2. All right. After you've done all that, you can pick any equation you want. You can choose this equation, any of the equations you formed here, any of the equations you formed here to solve for y. Doesn't matter to me. I think I'm just going to probably default to this one, but it doesn't matter. So I'm gonna go -3x plus 2 times 2 equals -14. So this gives me -3x plus 4 equals -14. Subtract the 4. -18 divided by -3. X equals 6. So our final answer here, we'll write as a coordinate. So it'd be 6, 2. All right. Let's do another one. If I was to give you 3x minus 4y equals 9 and 2x plus 9y equals 2. It's already in standard form, which makes my life a little bit easier. So again, all I'm going to do is I'm going to take the first equation and I'm going to multiply by this coefficient in front of x. So I'm going to multiply by 2. Then I'm going to take this equation and multiply by the opposite of this coefficient. So if this is a +3, I'm going to multiply by -3. This ensures that these will have the same numbers with opposite signs so that when I add them together, they eliminate. All right. And then I'm going to distribute. So that will give me 6x minus 8y equals 18. This will give me -6x minus 27y equals -6. And make sure you distribute it even to the constant. All right. After that, I'm ready to add them up. This will eliminate. -8y plus -27y looks to be like -35y. 18 minus 6 is 12. I'll divide by -35. That will go away. Don't think those will simplify. So that's just going to be a -12 over 35. All right. Now, the hard part is when you get an answer that's a fraction is plugging it back in. So again, I will probably default to the first one. It doesn't really matter. So I get 3x minus 4 times -12 over 35 equals 9. All right, 4 does not go into 35. That's a bummer. So ready? So therefore, we'll just multiply it out. So two negatives make a positive. 4 times 12 is 48 over 35 equals 9. I then need to subtract 48 over 35. So I get something like this, which is 9 minus 48 over 35. Put that over 1. 35 would be the least common denominator here. So it looks like I have 3x equals 35 times 9. 5 times 9 is, wow, 45. Okay, then 9 times 3 is 27, plus the 4 is 31 over 35 minus 48 over 35. I guess. All right, and then we got to do 315 minus 48. Bringing out a calculator. 315 minus 48. It's 267 over 35. But remember, this is still equal to 3x. So now I got to divide by 3. Dividing by 3 is the same thing as taking 267 over 35 times 1/3. I wonder if that will simplify. 267 divided by 3 does. So 3 goes into 267 89 times. So I get 89 over 35. So sometimes our answers are not nice and clean, but it's part of the algebra. All right, again, we write our answers as ordered pair. So it's 89 over 35, comma, -12 over 35. There you go. All righty. Now, after this point, after they force you to do their certain methods, then they'll allow you to do whatever method you would like. So it really just depends on your setup. If I have something like this, -4x minus 8y equals 2, and 2x equals 8y minus 4y, again, I like to default to elimination. If you like substitution, you can do it that way. Typically, if you're left with just a letter already by itself, go ahead and just solve for it. So I'm going to divide by 2. So this will give me x equals 4 minus 2y. And then once I have that equation, take that equation, plug it in for the other guy in the other equation. So that'd be -4 times 4 minus 2y minus 8y equals 2. Go ahead and distribute so you can solve it. So this will give me -16 plus 8y minus 8y equals 2. So therefore, those will actually eliminate, and I get -16 equals 2. Now, you have to ask yourself, is this a true statement? If it is not, that means this is a no solution. All right. A couple of things they'll want you to do is a no solution is an empty set and is also considered to be inconsistent. All right. So if you get a no solution, they might want an empty set, and meaning that it's inconsistent. All right, let's try another one. Let's try 2x minus y equals 8 and x minus 1/2 y equals 4. All right, this is in standard form. So I'm just going to use my process that I used last time. So I'll multiply the top equation by 1. So that's what coefficient's here. I'll multiply by the opposite of 2, which is -2. So this will just keep the same. 2x minus y equals 8. This will become -2x. A -2 times a -1/2 is actually a +1. This is going to be positive y equals -8. I see that the 2x and the 2 cancel. I also see that -y and y cancel. So I get 0 here. And I see that 8 plus -8 is also going to cancel. And I get 0 equals 0. Now, this is a true statement. 0 does equal 0. So if you get something like this would be infinitely many solutions. And let's see how they might want you to answer it. All right, so this is what they call a dependent answer. Dependent. But the way they want you to answer it, you don't have to do this for me, but for your homework, you might have to do this. So what they'll do is they'll have a set open up and they'll just ask you to solve for one of these letters. Okay. So let's say I want to solve for x because it's the one that has the best coefficient, right? So all I got to do is just add the 1/2 y. So this becomes x equals 1/2 y plus 4, or 4 plus 1/2 y, however you want to write it. And so what they'll do is they'll have you take that answer and they'll say, all right, well, this is going to be what x is. X is going to be just some random variable. But actually, sorry. X will be what you just solved for in this case. So 1/2 y plus 4. And then your y will just be some random y. If you solved for y, then it would be a random x and the equation that you solved for y for. Right? And they'll say where y is any real number. This to me seems a little extra, but this is what you'll have to do on your homework. I'm good with just infinitely many solutions if you get to this situation. All right, let's see what else they got. All right, so after all that, you gotta be able to do word problems. So this is objective 3 now. We will now use systems of linear equations in application. Alrighty, so this first example we have is a pharmacist wants to mix a 30% saline solution with a 10% saline solution to get 200 milliliters of a 12% saline solution. And it says how much of each solution should she use, sorry. All right, so this actually kind of goes back to unit 1 when we talked about solution mixture problems. So let's kind of figure out what information we have here. So it says a pharmacist wants to mix a 30% saline solution. So that would be 0.30 times some amount. So a pharmacist wants to mix a 30% saline solution with a 10% solution. So that would be plus 0.10 of some other amount to get a 200 milliliter of a 12% solution. So we want this to equal 0.12 of 200. All right. How much of each solution should she get? Huh. I want to make this 2 equations. We can do it in 2 equations, but I feel like this process might be a little bit easier. If I know that this needs to be X amount, and I know that my end result is 200, then I'll know that this result here, instead of it being a Y, it will be 200 minus X, which is what this amount is. So if we let 30% of whatever amount of solution, and then this has to then be whatever that is minus the 200 to get to my 200 here. They want us to then write this out as X plus Y must equal 200. And then you subtract for X so that you see that Y is equal to 200 minus X. That's fine. But we did this in unit 1 just fine without it. After this point, all you gotta do is just solve this. So this is 0.30x plus 0.10 times 200 is 20. For sure. Yeah, 10% of 200 is 20. Minus 0.10x equals 24. And then we can solve it. 0.3 minus 0.10 is going to be 0.20. Plus 20 equals 24. Subtract the 20, so I get 0.20x equals 4. And then I get, divide that by 0.20, and I believe that's 80. See, 4 divided by 0.20 is just 20. So 4 divided by 0.20 is just 20. 4 divided by 0.2. That's what I'm keep getting. All right, so so it'd be 20 here. Now it basically what we have to do here is write out what the answer is. So that means X represented my 30% solution. So I need 20 milliliters of the 30% saline. And if we take that away from 200, that would mean I need 180 milliliters of the 10% saline. And that will make a 200 milliliter of 12% saline. All right. So again, you can make this a system, do it this way, but I think the process we did in unit 1 is just as good. All right, let's do another type. All right, in this example, we have a fishing boat that travels along the east coast of the United States and encounters the Gulf Stream current. It travels 44 miles north with the current in 2 hours, and then it travels 56 miles south against the current in 4 hours. And we want to find the speed of the current and the speed of the boat in still water. All right, so let's see what information we got. So it says a fishing boat travels along the east coast of the United States and encounters the Gulf Stream current. All useless. It travels 44 miles north with the current. I don't think that's going to matter. With the current in 2 hours. So this looks like a distance equals rate times time problem from unit 1. So it travels 44 miles at a rate unknown to us in 2 hours. And then it looks like we have 56 miles against the current. So our rate would be with and the other rate would be against in 4 hours. The R's would not be the same here. So I feel like yeah, so I feel like you'll have a rate with the boat, and then you'll have a rate with and against the stream. So in this one, this is 44 equals so with the current, so you'll have your speed plus the speed of the river that you're traveling 2 hours with. And over here, you would have your speed, and then you'll be going against the current. So you'll have to fight against the current, and it takes 4 hours. So now the rates aren't the same because now we got your rate with the current, your rate against the current. And then so now we have two equations. Now we can solve them. I would suggest putting this in standard form. So I'm actually going to flip the equals 44 over while distributing at the same time. So I get 2x plus 2y equals 44. Same concept. I'm going to distribute and flip the 56 over. So this gives me 4x minus 4y equals 56. All right, so if we go through our process, you can do the process that I taught, and you can take this 4, multiply this, take the -2 and multiply it by this. But if you get really good at this, there's patterns to look at. The goal is to make these numbers the same, but then to basically get rid of them in a sense. So I can actually multiply this by -2, and it will make a -4, rather than having to multiply this by 4 and this one by -2. If you don't see that, you can always multiply by 4 and -2, and you'll get to the same conclusion. But the goal for me is to get y'all to go a little bit faster. So this would be -4x minus 4y equals -88. And then I'm bringing over the 4x minus 4y equals 56. And then add these up. This will cancel. This will give me -8y. 88 minus 56 would be -32. Divide that by -8 and we get 4. So that means the current, because this is miles and hours, the current, so find the speed of the current, is 4 miles per hour. And the speed of your boat, so your speed, or we'll go boat speed, is equal to something. All right, so all you got to do is take that 4 that you just solved for and plug it into any one of these equations. I always default to the first one, but it really doesn't matter. So this becomes 44 equals 2x plus 2 times 4. I distributed it and then also went ahead and plugged in. So this gives me 44 equals 2x plus 8. Subtract the 8 over, and I get 36 equals 2x. Divide by 2, and I get 18 equals x. So the boat speed is 18 miles per hour. All righty. All right, so we'll do one last word problem that you might see on your homework. It says a vendor at a carnival sells cotton candy and caramel apples for $2. The vendor is charged $100 to set up his booth. Furthermore, the vendor's average cost for each product he produces is approximately $0.75. Okay. So this is going to be a multi-step question here. First part of the question, it's going to ask you to write a linear cost function representing the cost CX to the vendors to produce X products. So basically, I want you to figure out how much it's going to cost the vendor. So that's going to be considered what we call C of X. So we know that it's a flat fee of $100 plus 75 cents per item that he sells. So it's going to be 0.75x. So for the cotton candy and the caramel apple, they sell $2 each. It costs 75 cents each. So that's how much it's going to cost the vendor. The second thing they want you to do is write a revenue. How much money does the guy get? So that would be your R of X. Well, he charges $2 each. So whatever he sells, it'll just be 2 times whatever that amount. So then the third and final thing, or sorry, not the final, but the third thing is determine the number of products to produce and sold for the vendor to break even. So to do that, all you got to do is take these two things and set them equal to each other. So this will be 100 plus 0.75x equals 2x. We'll subtract the 0.75x and we get 100 equals 1.25x, and then you'll divide by 1.25. And we get x equal to 80. So he must sell 80 items to break even. All right. The last thing it wants you to be able to do is if 60 products are sold, will the vendor make or lose money? So if he sold 60, would he make or break? Hopefully you are thinking, well, we just solved that he has to sell at least 80, so he would lose money. He would not have sold enough. And that's really as hard as this stuff gets. So if you have questions, let me know. 5.1 opens today, is due Sunday. We do have 3 other assignments due on Sunday as well, and they'll open up staggeredly on Tuesday, Wednesday, and Thursday. As you come up with questions, just let me know. Yeah, have a good one.